So simultaneous equations, what we have to remember, they are used when there is more than one unknown, as we can see here. And that's really important, just going through questions, because perhaps they don't tell you straight away what you need to be doing. It's important to remember when you have two unknowns, such as here, we have x and y. Just having one of these equations like this, we wouldn't be able to solve it because there's no way to find x and y here because there's so many different combinations of what they could be. For example, x could be 2 and y could be 1 and then 5 equals 5, but there's lots of different combinations it could be. So this is why we use simultaneous equations. When we have two equations with the same variables in each, x and y, we can solve them to find the individual values of x and y with 100% certainty. So to do this, we have 4 steps we have to remember and use. And these 4 steps are, first of all, we have to prepare the equation and in terms of its form and its coefficients. Next, we eliminate one of the terms by adding or subtracting the equations from each other. Third, we sub in and solve. And then fourth, we check it. Now, I get this is quite complicated because we haven't done it yet, but you'll see what I mean in this first example here. So first of all, preparing our equations, forming coefficients. To do this, when we take them away or add them, the coefficients of one of the variables, either x or y, have to be the same. So let's check if that's true. X, they're not the same. However, y, it is the same. They both have a coefficient of just 1. And then its form, they're both in the correct form of having, for simultaneous equations, you want both your variables on one side and then your real number on the other. And I get this is quite complicated, but you'll see why we do this in the next step. So in the next step, what we do is we need to get rid of one of these terms. So we either add or subtract the equations. Well, if we add them, that would give us 2y, and we want to get rid of the y's. So we minus them. So taking them away, how we do it is we subtract each similar term from each other. So 2x minus x gives us x. And as we are aiming for, y minus y is 0, so we don't need to write anything here. And then 5 minus 3 is 2. So now we can see we have x is equal to 2. So now we know x is 2 from doing our first 2 steps of simultaneous equations. Now, third, we sub in and solve. So now we know x is 2. We can sub that in to either of our equations. I'm going to sub it into the bottom equation for simplicity's sake. So our equation is x plus y is equal to 3. And then subbing x in, we know x is 2, x plus y is equal to 3. Then minusing 2 from both sides gives us y is equal to 1. So now we know y is 1 and x is 2. So we have solved our simultaneous equation because we know both their values. And just to check your answer, this isn't compulsory, but especially in exams and tests, it's really useful to do this to make sure you've got it right. So now we use this equation, so we're going to pick the other one. 2x plus y is equal to 5 and sub them in. So 2 multiplied by 2 and then 1 is equal to 5. This solves for 4, add 1 is equal to 5, which we know 5 is equal to 5. So we know our answers are correct. So there's our first example. Let's go ahead and take a look at our next example.